students, welcome to Kimshore. Today in this video we are discussing the topics effect of substituents on the acidity of phenol, that is as part of the chemical properties. Here we are discussing the effect of substituents on the acidity of phenol. This is very important topic and at the same time it's very interesting too. Okay. This presence of electron withdrawing group. Which are the electron withdrawing group? Yes, NO2, CN, CHO, COOH. This nitro group, cyanide group, aldehyde group and carboxylic acid group. There is the presence of electron withdrawing group such as NO2, CN, CHO, COH enhances the acidity of phenol. That is, the presence of these group, electron withdrawing group, increases the acidity of phenol. How? Can you guess how it is increasing the acidity of phenol? That is, this is because of the greater stabilization of the phenoxide ion due to the effective dispersal or delocalization of its negative charge through negative mesomeric or resonance effect. What is negative mesomeric or resonance effect? Mesomeric effect, M effect, in chemistry is a property of substituents or functional group in a chemical compound. That is, it is defined as a polarity produced in the molecule. Polarity means charge difference produced in particular molecule by the interaction of two pi bond or between a pi bond and a lone pair of electrons present on an adjacent atom. That is, resonance refers to delocalization of electrons in a given system. But mesomeric effect is the electron donating or electron withdrawing nature of a substituent due to resonance. Okay. There are two types of mesomeric effect, plus sum effect and minus sum effect. What is positive mesomeric effect? Positive means when the electrons or pi electrons, when the electrons or the pi electrons are transferred from a particular group towards a conjugate system. This electrons, that is this electron or pi electron or this electron is transferred from particular group towards this conjugated system like this. This increase the electron density of the conjugated system. Then such a phenomenon is known as plus sum effect. If it decreases the electron density on the benzene ring, that is conjugated system, that is called minus M effect, that is negative mesomeric effect. Hence, we are reaching at the conclusion, that is why this presence of electron withdrawing group increases the acidity of the phenol. That is, this presence of electron withdrawing group that produce minus M effect. That is minus M effect. Minus M effect means minus mesomeric effect, or we can say that minus R effect. Minus M or minus R effect. That is, here we can see the resonating structure of para-nitrophenoxide ion. It is unlike in the phenoxide ion, the dispersal of the negative charge is not only over the benzene ring, but where? But also spreads to the NO2 group in the para position, thereby achieving the greater stabilization than the phenoxide ion. That is, when electron withdrawing group is present at the para or ortho position. That is, para and acidic strength of phenol is much more pronounced when electron withdrawing group is present at the para position or at the ortho position. Okay. That is, when electron withdrawing group is present at the ortho or para position. What is happening actually? That is, the electron density on the benzene ring decreases due to the presence of electron withdrawing group. Actually, what is happening to this system? This electron withdrawing group decreases the benzene ring's electron density by attracting towards this NO2 group. That is minus M effect. Electron is shifted towards NO2 also. Not only present on the benzene ring, this is shifted towards NO2 also. Hence, you can say that the charge density at the oxygen is lesser, and it will always try to release the H plus. Okay, that is in the OH group of phenol. It will always try to release the H plus, moreover attracting it. Okay, that is the electron density on the O group decreased by minus M effect or minus R effect due to the presence of NO2 group. This electron withdrawing group. Not only NO2, that is both all these groups, electron withdrawing groups, NO2, CN, CHO, COH, etc. Electron density will be reduced by minus M or minus R effect. Hence, we can say that here at the oxygen's position, the electron density is lesser, and it will always try to release H plus, moreover attracting it. Okay, hence we can conclude that when electron withdrawing group is present as substituents in any of the benzene ring, any position of the benzene ring, it will always try to decrease the electron density on the benzene ring, and it increases the acidity of the phenol. But this effect, that is acidic strength of phenol, this effect is more pronounced when such group is present at the ortho and para position. That is important. Hence, we can say that para-nitrophenol has a greater tendency to donate a proton than phenol and is thus more acidic than phenol. That is, para-nitrophenol para-nitrophenol is more acidic than phenol. That is, the presence of electron withdrawing group increases the acidity of benzene ring. Okay, so we can say that para-nitrophenol is more acidic than phenol. Let us discuss the acidity of phenols. It is order of acidity of nitrophenols and phenols. Okay. Order of nitrophenols and phenol. Okay, which is the order which is more acidic, that is para-nitrophenol. and which is less acidic, that is phenol. Okay, that is this effect is more pronounced when such group is present at the para and ortho. And among ortho and para, which is more acidic, it is para. Okay, don't forget this point. This is very important. Okay. Now next we are considering. Now next we are discussing, that is, increasing number of electron withdrawing group substituents increases the acidic strength. That is, if NO2 group is present more than one. If more than one NO2 group is present in one benzene ring itself, you can say that its acidity increases. Okay. Hence we can say that here we are putting 3 NO2 group. Okay. 2, 4, 6. 2,4,6 trinitrophenol. We can call it as 2,4,6 trinitrophenol. Next, we are substituting 2 NO2 group. Okay, here at the para position and at the ortho position. Two, 4 dinitrophenol. That is 1, 2, 3, 4. 2, 4 dinitrophenol. Okay. Next, we are substituting only one nitro group here at the para position. And which here. Four nitrophenol or para-nitrophenol, and finally phenol. That is, the order is just like that. It is greater than simple. 2,4,6 trinitrophenol is more acidic. That is, it contains more electron withdrawing group as substituents. Okay, hence the order is like this. Okay. All of you got it? Next we are discussing the electron releasing groups. That is, the presence of electron releasing group and effects on the benzene ring. That is, what is happening when electron releasing group is present on the benzene ring to the acidity of the phenol. It is the presence of electron releasing group, which is the familiar electron releasing groups to you. It is alkyl group, CH3, one of the important alkyl group. That is, electron releasing group is the alkyl group. Next we are discussing the effect of substituents, that is electron releasing group such as alkyls, NH2, OH, OR at ortho or para position with respect to the next we are discussing the effect of electron releasing group on the acidity of phenol. Okay. It is electron releasing group. Which are the electron releasing group familiar to you? That is one of the important CH3. It is alkyl group, NH2, OH, OR, etc. substituents on the benzene ring. Okay, let us discuss. That is, when these groups are present at the ortho or para position with respect to the OH group, tend to destabilize the phenoxide ion. That is, it always destabilizes the phenoxide ion by intensifying the negative charge through the electron releasing by positive mesomeric effect or resonance effect. We had already discussed what is positive mesomeric effect. That is effect of electron releasing group. The presence of electron releasing group in as substituents increases the electron density at the benzene ring. Hence, the charge density at the oxygen atom is increased. Hence, we can say that negative charge is increased here due to the increased electron density present at the benzene ring. The electron density at the oxygen atom is increased. Hence, this negative charge, this oxygen, always try to attract H, moreover releasing it. Okay. Hence, we can say that acidity of phenol is decreased by the presence of electron releasing group. Okay. All of you got it? That is Plasm effect or Plasma effect. Okay. Hence, do not favor the formation of phenoxide ion. This results in a decrease in acid strength of such a phenol. Let us discuss the example. Okay. CH3 here. It is CH3 as a substituent at the para position. You can call it as paracresol. And here CH3 at the ortho position. That is orthocresol. You can name it as orthocresol. Paracresol, orthocresol, and finally metacresol. Okay. Now next we are discussing one important point, that is for CH3 group plasm effect, due to plasm effect the acidity of phenol is decreased. Okay, that is if CH3 group is present as a substituent, the acidity of phenol is reduced. But the groups like NH2OH, OR, when present in meta position, what is happening to the acidity of the phenol? Actually, these groups present at the meta position increase the acidity of phenol due to minus I effect. That is, in these three groups, minus I effect predominates over plasm effect. Okay, that is when electron releasing group such as alkyl group is present at the ortho and para position with respect to OH, tend to destabilize the phenoxide ion by intensifying the negative charge through electron released by positive mesomeric or resonance effect. So we can say that they do not favor the formation of phenoxide ion. Okay. This results in a decrease in acidic strength of such a phenol. But when groups like, even though these are electron releasing group, but Due to dominant minus I effect, these groups, presence of these groups in on benzene ring as a substituents increases the acidity of the phenol. Now next, what is minus I effect? Minus I effect, that is inductive effect. The effect on electron density in one portion, that is effect on electron density in one portion of a molecule due to electron withdrawing or electron donating groups. That is effect on electron density in one portion of a molecule due to electron withdrawing or electron donating group in the molecule. There are two effects, that is positive inductive effect and negative inductive effect. Here dominating negative inductive effect. Positive means refers to electron releasing tendency of functional group. Electron releasing tendency of the functional group. Positive inductive effect. For example, alkyl group. Alkyl group has positive inductive effect. This alkyl group has positive inductive effect. Positive inductive effect, that is plus I effect. Okay. Alkyl, aryl, metals, etc. But negative inductive effect refers to electron accepting tendency of functional group. Electron accepting tendency of a functional group. That is why alkyl group are showing positive inductive effect. Though the CH bond is practically considered as non-polar, that CH bond is non-polar, there is a somewhat partial positive charge on hydrogen atom and a partial negative charge on carbon atom. Therefore, each hydrogen atom acts as an electron donating group. This cumulative donation turns the alkyl moiety to an electron donating group. Okay, and so we can say that alkyl groups are showing positive inductive effect. Next, types of inductive effect. Next, negative inductive effect. That is electron withdrawing nature of groups or atoms is called as negative inductive effect. It is indicated by minus I. Following are the examples in the decreasing order of their minus I effect. That is, here we want to know that only one. That is, here we want to know only one thing, that by the presence of NH2OH group at the benzene ring as a substituent, it seems to be increases the acidity of the phenol. That is, acidity of the phenol is increased due to the presence of NH2OH and OR group, even though these groups are electron releasing group. Okay, due to the why? What is the reason? That is, here in these groups NH2OH and OR, negative inductive effect is dominating. Negative inductive effect is dominating, and so we can say that electron withdrawing nature of group. Electron is withdraw from the benzene ring. As a result, the negative charge is electron charge density is reduced at the oxygen atom. So you can say that this will always try to release the H plasma by accepting it. Okay, it increases the acidity of the phenols. Okay, all of you got it. Hence we can say that groups like NH2OH, OR, when present in meta position, it increases the acidity of phenols due to minus I effect. Okay. Hence we can generalize the concept that the presence of electron withdrawing group increases the acidity of the phenol and the presence of electron releasing group decreases the acidity of the phenol when present at the ortho or at the para position with respect to the OH group. Okay. Here we can see the acidic strength in respect of para-nitrophenol, phenol and para-methoxy. This is a group called methoxy, para-methoxyphenol. That is at para position, the group attached is OCH3 group, which is electron releasing group, which is an example for electron releasing group. So we can say that order of acidity is like this. Okay. Because if you have any doubts regarding this section, you can ask doubts in the comment section. I am giving answers for you. This is one of the important portion of this chapter. It is acidity of phenol and what is happening when electron withdrawing group and electron releasing group is added at the benzene ring. This effect of substituents on the acidity of phenol. For the examination point of view and as well as for your competitive exam, this is very important. Let us wind up the section. Thank you.